Hello, welcome to another video about Fusion 360, talking about more joints, specifically this time, more complicated joints than just the simple revolute and cylindrical joints. We're going to be talking about putting hex bars together with hex hubs and creating sliding joints. Now, also please bear in mind that for a lot of these things, there are usually, if not always, several ways to do basic things in CAD. So the way that I'm going to show it is definitely not the only way. And if you find another way that you like that works pretty well, feel free to use that one. But this is the method that I like to use, right? So let's first talking about attaching things like hex hubs to a hex shaft. In this case, this is a half-inch hex shaft, meaning that this top plane is half an inch away from this bottom plane. When I measure it, you can see it's 0.5 inches top to bottom. And the inner diameter, or sorry, not inner diameter, it should be the same for this, which is approximately 0.5 inches. If you import CAD diagrams of other parts, it's possible that it's slightly more than 0.5 inches or slightly less. And the method that I'm going to show you will work for both of them, but it won't necessarily be like perfectly centered, right? Let's demonstrate that using the joint. Now you can still use this using the simple joint tool by clicking the button, going down to the assemble tab, or simply pressing J. And an important thing to point out about joints that I didn't talk about in the previous video is that what you select as component 1 and component 2 is really important. Component 2 is the thing that is being moved to. Component 1 is the thing that is being moved. Now, essentially what this means is that if you don't have something grounded, if you effectively want something to not move, you can select component 2, and it shouldn't normally move. There are likely exceptions to this, though. And component 1 will be the one moving, especially in the animation, right? So if we go ahead and select, and this is how I do this, right? So I will first off go and select this. I'll go up over here, and I'll either click, or I'll select over to the snap, and I'll click this top plane, which can sometimes be tricky to select because it'll try to auto-select a different plane, but we can still do it. And then I go over to the motion tab, and I click planar. If it's already on planar, I will click it to something else, and then click it back to planar, and that will usually reset the tool. Now, as you can see, I put it here, and this is not exactly the way that I want it to be, right? It's in a way that, I mean, it's kind of aligned, right? But it's also kind of terrible because it's upside down. So what we can do is hit the flip button. Now you can see I didn't fix it, so you have to hit it again. I believe this is likely a glitch within the Fusion 360 software, and it might vary based on operating system. But basically what you can do if you think that a joint is weird is you can just toggle it back and forth until it's in the right position, right? And then we'll hit OK here. Now something you'll notice, I should actually ground this particular part first. Let's go ahead and ground this. I can actually move, I should be able to move this around. Let me make this a new, or at the very least, it should be its own thing. Oh, I grounded the wrong component, my bad. I should be making this into a new component, and I should be grounding this. And you'll see I can move this around, and when I move it around, it's in the same plane, as indicated by this, right? And if I go to the side here, it's moving around like this, just side to side. Or at least it appears that way. If I go to the top and I move it around like this, it stays with this plane being in the same plane as this underside one here, right? Now, how do we get this to actually slide on the hex shaft? Well, we do another planar joint. So we can click here and then we can click here. Oops. I did not mean to do that. Let me deselect this and select the actual plane. I'm not sure why it's selecting the line. There we go. Okay. And then we toggle it. Okay, sometimes you don't have to toggle it and it will do it on its own. But one thing you'll probably often see when doing these types of joints is it'll give you a warning. And to resolve that, you can toggle back and forth until it's in the right position. And even though it's facing perpendicular to the hex bar, when I hit OK, it will joint correctly. Now, if you get this sort of perpendicular joint on your first planar joint with this, you're going to want to go ahead and rotate it. I understand that the rotation can be weird. It looks like the rotation is on this front YX plane here if we sort of swivel around, but the way it rotates is absolutely not that, right? When we rotate this like this, it sort of moves in a weird direction. So just bear in mind this rotational thing might not necessarily always correspond to something that like makes sense in terms of directions, but as long as you align it correctly, it should be okay. Now, it looks like it's disaligned, like this top plane is no longer aligned with the hidden underside plane inside there that we can't see at the moment, but when we hit OK, it aligns itself correctly. And if you don't want to see these joints, which I recommend you don't want to see them, you can click on the joint either by clicking on it here carefully or opening the Joints tab and clicking on it. But if you go to the Joints tab and you want to hide them, you can just click on the eye icon. But the way I do it is, because I don't like to open the Joints tab, is I click on it and I hit V, and I click away. Hang on, that didn't work because I clicked something wrong. I hit V and it goes away. And I click on it, hit V, goes away, but using the eye icon works all the same. And you can also show and hide all joints. So if I have these, so if I have both of these visible, I can toggle this eye, right? So I'll just go and hide both of those. Sometimes you'll want joints visible, sometimes you don't. So this is how you make a hex thing have sliding motion on a hex shaft. And if you want to limit how far it goes, and we'll just go into this, you can use another planar joint. And what we'll basically do is we'll click here, and we'll click here, and we'll hit continue. We'll toggle this back and forth quickly until it's the way we want it. We'll hit OK. And you'll see it's stuck here now, right? But if I go here, and I now hit either drive joints, which is one thing I should be able to do. Oh, no, it's not drive joint, my bad. We right click it and we hit edit joint. We can move it like this, or, no, I think that is the best way to do it. Yeah, edit joint, and you can move it whatever distance you want here. So say I want it to be 4 inches in, right? I can do this, and it's now locked here, essentially. And even if I hide this, I can go back into the Joints tab, and I can modify this later. So that is the mating things to hex shaft part of the video. And now, as you've probably seen in flashes throughout this video, I have some very large 2x2 and 2x1 tube bars. A little irritating that this capitalization is inconsistent. That's my inconsistency, I apologize. And what I'm going to do first is I'm going to ground this one so that it doesn't move, just for the sake of our sanity here. And our goal with this is we essentially want to create a sliding joint, right? And for the purposes of this particular joint, I want this to sort of be in the middle, and we can imagine there are other components that exist in the thing that we're CADing that allow this to be situated in the center correctly. But for now, we just want to create a sliding joint. So how do we do it? We click the joint button, and if something is grounded and you're selecting component 1, it won't actually allow you to select the thing that's grounded until you select a component 2, because things that are grounded can't move until you unground them. So we'll go ahead and click on component 1. Technically, it doesn't matter which face you select, but ideally, you'll click a face here, you'll click this, and you'll click a face inside for this particular example of tubes, and you'll hit the slider joint. And you can see it's kind of garbage. This is not at all even close to what we want. So what we can do to fix this, first off, is we want it to move in the correct direction, but we also want it to be facing the correct way. I don't think anyone has a slider joint that looks like this, right? So first off, what we need to do is we need to rotate this into the correct position. Now, if you remember how what I said before about the rotation not seemingly matching the correct plane of rotation that it's in, this is another one of those. And so you have to rotate it to the correct position that you want. In this case, I want it to be 270 because I want it to be straight up and down. And we'll hit OK, right? Now, I've just done that, but we're technically not actually done. So I'm going to go back in and edit this joint. And what we're going to do, if we play the animation, we still see it's not in the direction we want. So we change the axis. Sometimes it might automatically be what you want. Sometimes it might not be. I don't know exactly what the formula is that sort of predicts this, but in any case, if it's sliding a direction and you don't want it to slide that direction, you can change it to, say, the x-axis. And in this case, it looks like the x-axis is what we want, although it doesn't seem to actually always correspond to what the z, y, and x-axes are, but I imagine there must be some consistent logic going on inside of Fusion 360. Now, the other thing I want for this, though, this is more semantic, is I want this to be centered, right? So we can sort of figure this out by moving this along and maybe eyeballing it a little bit. And we'll move it here. I believe this is actually supposed to be 0.375. And then we'll just hit OK here. And then we can try and measure this maybe. And how you do that is going to inspect. Can you hit I to inspect? Yeah, you can hit I to inspect. You can click 2 planes. we can see 0.365. We'll click away and we'll do this. And we can go back and edit this joint again since I want this to be perfectly in the middle. So we'll go ahead and do, what was it again? I think it was it 1? It might have been. I mean, we can always check, right? So we'll do this. Okay, yeah. So it looks like this is correct now. And we'll go ahead and hide this joint. But there is one more thing I want to show you related to sliding joints. So now if we move this, you can see it goes up and down pretty vigorously, right? It can go all the way below and it can go all the way up. However, this might not be what you want. You might want a joint that exists within a working model of, say, a robot that isn't going to slide all over the place, right? And can somewhat realistically represent reality. And the way you can do that is by introducing joint limits. So if you open up the joints tab and you find your joint, or if you haven't hidden your joint, you can either hover over it in the joints tab and hit edit joint limits, or right click on it and hit edit joint limits here, or right click on it here if you haven't hidden it and hit edit joint limits. Multiple ways to do the exact same thing. You basically just want to edit the joint limits, and it is sort of as it says. You can set the maximum and the minimum. Now, the funny thing about the maximum and the minimum, of course, the numeric value in the maximum field must be larger than the minimum value. It doesn't work. Off of absolute values. And the reason I say this is because I've confused myself before, because the direction of this is not always consistent. Sometimes a minimum of, say, let's do like 16 is going to be in the upwards direction. In this case, it's the downwards direction. So say I have it at 8, let's say I have it at 0, right? So in this case, this is as low as I want it to be, and this is the value being 0, which is as high as I want it to be, and it's 0. Isn't that kind of weird? So I leave 0 as maximum, and it's possible that it's flipped and that might end up being your minimum. So I switch over to the minimum. Say I want it to go up, this bar is 32 inches long. Say I want it to go up 16 inches, just like for hypothetical. Well, this is obviously not the right way. I need to be negative 16. And also when you put in a number, it automatically updates it to that particular extreme. We'll set this back to 0, and now we can see is that if we animate it, it goes up and down in the exact way that we want. And it also has like a rest position. So we hit OK here, and now what we see is when we try to lower this down, it doesn't go any lower than the limit that we set, and it doesn't go any higher than the limit that we set either. We can vigorously try to smack it against its ceiling, but it's not going to go any higher. And this is how you create a sliding or locked hex joint, and that is how you create a sliding / limited slider joint.